What we're going to do is we're going to graph natural log. We've been graphing log, and now what we're going to do is we're going to look at natural log. It's going to be the same process. We're going to find our vertical asymptote, which is always our h value. Then the two values we're going to pick are 1, just like before, and e. Now, before we've been looking at the common base, and in this case, we're doing the same thing because natural log, if you remember, is log base e. So that means that all of the natural logs are going to have the same base. It's going to be e. Now, e is an irrational number, so it keeps on going. We're not going to do the whole number. What we're going to do is just focus on 2.7. And the reason why is because whether I plot 2.7 or 2.718, it's basically going to be the same spot. All we're doing is plotting it to get an idea what the graph generally looks like. So what we're going to do is we're going to look at the first one. And with the first one, we have our vertical asymptote at 0. And the reason that it's at 0 is because there's no parentheses. So we know that whenever the log is 0, it's undefined. Then what we're going to do is we're going to do our table of values. And with our table of values, we have our two numbers. We have 1 and e. And remember, I'm putting the 2.7. When I plug in a 1, the natural log of 1 is always 0. So 3 times 0 is 0. When I plug in the 2.7, natural log of 2.7 cancels. It becomes 1 because really technically we're putting an e, and that would be the same base. So 1 times 3 is 3. So when I'm graphing this, what I'm going to do is I'm first going to put in my vertical asymptote. And so my vertical asymptote is at 0. And then what I have is my points. I have 1, 0, and I have 2.7 and 3. And then what I'm going to do is I'm going to graph it. And remember, I'm going to do domain and range. And domain and range is going to be exactly just like the logs. The domain is going to be 0 to infinity. And the range is going to be negative infinity to infinity. So for the second one, once again, vertical asymptote is going to be 0. Notice there's no parentheses, so it makes it really easy. X is equal to 0. And for our table of values, once again, same thing, really easy. We're always going to use 1 because 1 is always 0. But in this case, we're adding a 2. So 0 plus 2 is 2. And then we're picking our number 2.7, which remember is e. Natural log of 2.7 is 1, but there's a negative in front of it. So that would be negative 1 plus 2, which of course is 1. So we have our vertical asymptote at 0. And we're plotting our points 1 and 2 and 2.7 and 1. And that would be our graph. And when we're looking for our domain and range, our domain is going to be, once again, 0 to infinity, because that's where our asymptote is. And our range is always the same, negative infinity to infinity. Now, if we're looking at letter C, the vertical asymptote is going to be a little bit different. Our vertical asymptote is, since there's a parenthesis, is x equals, and what gives us 0 inside the parenthesis would be negative 2. So that's our vertical asymptote. Now, when we're coming up with the points, we also have to think pretty cleverly. We're thinking about what would give us these values inside the parenthesis. So of course we want 1. So what would give us a 1 inside the parenthesis? And that would be a negative 1. When we plug in the negative 1 plus 2 is 1. Natural log of 1, of course, is 0. Minus 1 is negative 1. The other number that we want is 2.7 because that's e, or technically the estimate of e. In order to get a 2.7, what we need is a 0.7. So we're going to plug in a 0.7. Plus 2 is 2.7. Natural log of 2.7 is 1. 1 minus 1 is 0. So we have our vertical asymptote at negative 2. And then when we plot our points, what we have is -1, -1. We have 0.7 and 0. And this right here gives us our graph. Our domain, if we're looking at it, goes from -2 to infinity. And then our range is going to be -infinity to infinity. So looking at our next ones, we're going to do the same thing. First thing that we're going to do is we're going to look for our vertical asymptote. And we get x is equal to 0 because there's no parentheses. We have our table of values. Once again, we're using our same values. It's 1 and 2.7. We know that the natural log of 1 is always 0, times 2 is still 0. Natural log of 2.7 is 1, times 2 is 2. We're going to draw our vertical asymptote at 0. And then for our table of values, we have 1 and 0, and then we have 2.7 and 2. We're going to look at our domain and range. Domain, our asymptote is at 0, so 0 to infinity. And then our range is always the same, -infinity to infinity. Letter E, we're going to do our vertical asymptote. And our vertical asymptote is x is equal to 1 because we're trying to figure out what gives us a 0 inside the parenthesis, and we know 1 minus 1 is 0. Once again, we have to be clever to figure out what our x values are. And so what gives us a 1 here would be a 2. 2 minus 1 is 1. And of course, the natural log of 1 would be 0. What gives us the 2.7? Well, that would be 3.7. 3.7 minus 1 is 2.7. Natural log of 2.7 would be 1. So when we plot this, we have our vertical asymptote at 1. We have our 2 and 0. We have our 3.7 and 1. And that right there gives us our graph. When we're looking at our domain, it would be 0 to infinity. And when we're looking at our range, we have -infinity to infinity. So for our last one, our vertical asymptote, we have x is equal to -1. And then when we're doing our table of values, what gives us a 1 would be a 0. 0 plus 1 is 1. Natural log of 1 would be 0. Minus 2 is -2. What would give us a 2.7? That would be a 1.7. 1.7 plus 1 is 2.7. Natural log of 2.7 is 1. 1 minus 2 is -1. So we have our vertical asymptote at -1. And when we plot our points, we have 0, -2. We have 1.7 and -1. And that right there would be our graph. When we're looking at our domain, what we have is -1 to infinity. And when we're looking at our range, it's -infinity to infinity.